and welcome back to Virtualizing Your Data Center with Hyper-V and System Center. I'm Simon Perryman, joined again by Matt McSpirit, and throughout the rest of the day, we're really going to be focusing on how to further optimize your Hyper-V deployments. So in the morning, we kind of traveled through the basic host configuration. We set up our fabric and our infrastructure. We connected our networks, connected our storage, and then we built a cluster. We're now really going to try to take it to the next level, put our VMs on top of it, and then start to really try to optimize it towards being a private cloud. But before we get to some virtualization, I'm going to have some fun with you guys. You know, every time I try to present, I always try to find, some jokes to tell. And I was searching online for some virtualization jokes. I mean, Matt, do you know any?
No.
You know what? It's virtually impossible to find any. So what I want you guys to do is tweet me at Simon Perryman. The best virtualization jokes I get, I will send you a copy of this awesome book, Introducing System Center 2012 R2, and send it straight to your house. So tell me your funniest virtualization jokes. We'll share some of them a little later and see if you can make us laugh.
Yeah, for the worst one, Simon will sign it for you.
Only the worst ones.
Yeah.
Well, with that, we're going to move on and start to focus on virtual machine configuration. This module is going to be approximately 90 minutes, first talking about our VMs, talking about mobility with our virtual machines, talking about disaster recovery and replication. So we're really trying to take our core configuration, put our VMs on top of it, and start to optimize the configuration.
Yeah, so as Simon said, this morning we covered a lot of the storage, the networking, the host config. Now we're going to start layering stuff on top in the form of VMs and then look at how they're resilient, how we move them around, and how we optimally configure them within our environment. And I'm literally going to duck straight into a demo now. So without further ado, let's pop over to my virtualized environment. Again, we're back in VMM. This should be relatively familiar to you by now. We've got the cluster that Simon successfully built with all these years of experience earlier on. So Contoso cluster and our two Hyper-V hosts. And I'm in the Create VM wizard, which to get to that, I've just clicked the Create a Virtual Machine in the top left. And I'm going to just take you through a completely blank vanilla virtual machine creation. So this isn't using any templates. This is the slowest, most manual way of creating a VM. So I'm going to go through this wizard. But first, in 2012 R2 in Hyper-V, we introduced a new VM generation. So for a long time, the VM hardware has been relatively the same up until 2012. And that's what we now call and refer to a Generation 1 VM. However, I have this option when creating a VM, and it is at creation time, I can specify it to be a Generation 2 VM. And as you'll see in the bottom here, Generation 1 machines have capabilities previously supported by 2012 and other host operating systems. Gen 2, however, have new capabilities, such as the BIOS, the firmware of the VM, is essentially a UEFI, a Unified Extensible Firmware Interface. And it opens up the ability to boot from the synthetic network adapter, which we could not. And for Gen 2 VMs, the host must be 2012 R2. So I can't take a Gen 1 VM and run it on a 2012 host. Sorry, a Gen 2 VM. I can't take it back. And there's information and links for some of the other Gen 2 features, and we'll touch on some of those in the slides as well. So I'm going to call this one VM01. It's going to be Generation 1. If I click Next and go into the Configure Hardware option, you'll see I get quite a few options here. One of them is an IDE device, of which a Gen 1 VM boots from IDE, but you can attach supplementary drives to the SCSI adapters, and each VM can have 4 of these SCSI adapters, each with around about 64 or so virtual disks, so about 16 petabytes of storage per VM, hopefully that's enough for most people. If I just go back actually previous and change that to Gen 2, just so you can see the impact it has on the hardware options, you'll see IDE has disappeared. We're now booting from SCSI, which may be more relevant to those who've come from a VMware background. You may be used to that. That's the typical default choice. There's no IDE concept in there. From a Hyper-V perspective, Gen 1 does obviously have that capability. A UEFI firmware also supports secure boot, just like you'll get on a physical system to enhance protection against things like rootkits, pre-OS attacks, if you will. But I'm going to deploy Gen 1 because I want to explore all of the options. So hopefully that gives you a bit of a segue, and we'll touch on some more stuff later on in the slides. So from a CPU perspective, I can specify how many processors are important to me for this particular workload, and if I'm moving VMs, or I intend to move VMs, between hosts that are slightly different from a CPU perspective, maybe one generation of Intel to another, or one generation of AMD to another, then this particular tick box will allow me to migrate the VM with no compatibility problems. However, it's not going to allow me to magically move VMs from Intel to AMD. In terms of memory, I can statically assign memory to a VM, or I can turn on what we call dynamic memory. And dynamic memory allows me to specify a number of options for the memory. So much so that I can specify what the VM should start up with, because think about it. When a VM starts, it typically needs a little bit more RAM to get its services started, its stuff going, and you don't want to necessarily page out to disk at that point inside the VM. You want to utilize memory rather than start in-guest paging. So having a startup RAM that's a little bit higher perhaps than what you think classify as the minimum could overcome that particular hurdle. Then we look at the minimum memory. In this case, I'm setting it lower than the startup, so that after the VM has started, if it ever gets into an idle situation, it can drop down that little bit lower. And then the maximum, remember in our environment, it's a relatively small host, 2 gig of RAM, so our VM is going to be relatively small as well to let us show some of the placement options. So I'm going to set the maximum. And Hyper-V will accurately and intelligently fluctuate the memory within that particular virtual machine based on the changing conditions of that VM. When it needs more, Hyper-V will give it more. When it needs less, it will reclaim that memory and give it to another virtual machine that needs it. And the end goal of dynamic memory is to increase the density of our particular Hyper-V hosts. So this isn't using transparent page sharing, it's using effectively a ballooning driver within the virtual machine to push the memory out and reclaim it in a way that's intelligent for the particular virtual machine itself and in reflection of the guest operating system. And that supports both Windows and now Linux workloads as well. Now if we scroll down and look at some of the other options on the IDE devices, I'm going to look at this hard drive. I'm actually going to make the size of this relatively small. It's going to be dynamic, so it's going to be thin provisioned. This would be a thin VMDK if you're coming from the VMware world. We call them dynamic disks, sometimes thin provisioned virtual disks. There is other options such as fixed, which will fully zero out the virtual disk on deployment time. So your size in your physical environment will be whatever size you type in this box. Whereas with dynamic, even though I've specified 5 gig as the maximum, the actual size on physical disk will be very minimal and it will grow into that size. It's got a name, that's fine, I can leave that as is for now. And I've also got the opportunity to classify my particular storage if I need to as well. Now from a networking perspective, I want to join this VM to a particular network. I'm going to click Connected to a Network and I'm going to choose the only network I've got available to me, and that's Contoso LAN. Think back when we created our logical networks before. One of the options I created was also create a VM network that connects to this logical network. What this means is any VM that's attached to Contoso LAN will be able to communicate on the Contoso LAN that hosts are also joined to as well. So I'm going to do that as well. Imagine this is a VM that's also used for management, for instance. Now, do I want to change the MAC address? No, I'm going to leave that as is. I'm not going to change any of these different pieces. I can apply a port classification though, and I'm going to choose Contoso standard port. And what that means is it's going to apply all of the policies that we defined as part of that classification on this VM. So this VNIC for this VM is going to have router guard turned on, DHCP guard turned on. Remember those settings we tweaked earlier on for the virtual network profile, the port profile? It's being masked behind this name, Contoso standard port, but that's what's going to happen at deployment time. Now when we think about availability, I want to make this VM highly available, resilient, clustered if you will. Now to do that, I tick this box. So when VMM is going to place this virtual machine, it's going to look at the hosts that have got clustering enabled, and it's going to recommend those over standalone hosts, which aren't going to meet the requirements to make this VM highly available. Now, Simon mentioned before anti-affinity, keeping VMs apart on a clustered environment, because the last thing you want if you've got two related virtual machines, you don't want them sitting on the same physical Hyper-V host. You want them to stay apart as much as possible, especially if they are a guest cluster. And to do that, I use what's known as an availability set. And in VMM, I can click Manage, I can create a new one, and I'm going to call this Lab Availability Set. Should have picked something a bit easier to spell there, but I think I've managed it. There we go. Okay. And I click OK. And what this means is now any other VM that is added to this lab availability set should be kept apart by VMM. But it is a soft rule. It's not a hard enforced rule in the sense that if there is nowhere else for this VM to go, then it's going to break that rule and it's going to reside on the same host.
Right. For example, if you only have 4 physical hosts and you have 8 virtual machines, you're going to pair probably 2 on each of those hosts. We're still going to place it, but it may not be isolated one for one.
Yep. So I'm going to go and click Next and select the destination. Now we're going to talk about clouds later on, but you can see that's grayed out for me at the moment, deploy the virtual machine to a private cloud, so it doesn't matter about that for the time being. I'm going to place this VM on a host. I could put it in the library for later consumption. I'll just choose hosts. And what we should hopefully see, all being correct, is VMM go away, it scans our 2 hosts and comes back with some kind of message that says, okay, these hosts are suitable and you can place them on either of these. They've both got 4 stars. If I look at the rating explanation, there's not much available memory, but we can push through that. I think we need to adjust those host reserves. I'm not sure if they stuck before on the Hyper-V hosts, but at the end of the day, it's going to still succeed and the virtual machine is still going to get deployed at this point. We're going to transfer this from the VMM library over the network, so we'll go Next. And the final things that I need to tweak are just a couple of VM settings. For instance, where is this virtual machine going to reside from a storage perspective? In this case, we could use our file shares that we've made available to VMM. We could use our cluster shared volume that Simon created earlier on. I'm going to use FS01 because I'm going to demonstrate deploying to a file share, so SMB storage, remember we talked about earlier. From a networking perspective, this VM is going to get its IP address dynamically, all of that kind of stuff is going to be configured on the fly. And from a virtual hard disk perspective, it's going to reside in the same location as the config file for the VM, and it's going to be, we'll just leave the name as it is. I don't think I really need to change that at this point. So we can click Next. Any final settings? When the virtualization server starts, when the host starts, do you want to always turn on the VM? Turn it on if it was running before, never turn it on automatically. If you do want to turn it on, do you want to delay? Maybe 5 seconds, for instance. If the virtualization server stops, if you shut it down, do you want to save the state, turn it off, or shut down the guest? And finally, what operating system are you going to install in here? It's not going to change any of the settings we've previously made, but it'll help VMM administer and manage that particular machine. And finally, before I click Next, I'm going to untick and make sure this box is unticked, this Start VM after deployment, because in the nested virtualization world, that VM is going to fail. It's not going to be able to start, but at least we can deploy the VM. But I want to hone in on this particular View Script button, because here we've got the script that's going to get deployed, or going to get executed essentially under the covers for VMM to actually deploy that VM. And there was a question earlier on the discussion by the side of the slides and the presentation, where do you store these PowerShell scripts? Where should you put them? Well, you can put them pretty much anywhere that are accessible to you, or you can store them in the VMM library and run them and access them from there across all of your admins. So I'm going to go File, Save As, and I'm going to place this one in if I look in my VMM library, here we go, and I'm going to call this one something a little bit more relevant. I'm going to call this one deploy vm.ps1. I think that's accurate for what I want to say. Yep, deploy vm ps1, save as type, all files, save. So that's now is saved. I'm not going to run that or anything now. I'm just going to go back to my wizard and click create. And hopefully what we should see is VMM will go ahead and it will orchestrate the creation of that virtual machine. It shouldn't take very long. It's a dynamic virtual disk. Boom, 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 you see it happening there. We're not going to start it up, but that's the process of creating a new virtual machine. And we touched on Gen 1 and Gen 2 as well. Now that's a single VM. But what about if I want to reuse and utilize that PowerShell? Well, what I'm going to do is I'm going to open up my intelligent scripting environment, my PowerShell environment that gives me a little bit of a helping hand, not being a PowerShell guru like Simon. I'm going to open up my existing script that is in my VMM library, because I'm going to make some edits to it. And this is an environment that's a bit more intuitive for me to edit. So there it is. It's brought it all in, nicely color-coded, all that kind of stuff. And I'm going to do a find and replace essentially. So I'm going to do an edit, replacing script, and I'm going to find something, in this case VM01, and replace with, yep, you've guessed it, VM02. I don't need to do anything else. So if I replace, could just replace all. Right, okay, that's done. So now we've got VM02 that should be the standard option to deploy. So in theory, all being well, fingers crossed, I should be able to click the green arrow to run script, and what we should see is another VM being created. Are we ready?
Let's give it a shot.
Dun, dun, dun. Looks like it's doing something.
Now, if we go take a look at the jobs, we should be able to see that running in the background, right?
Well, we should. Or maybe I need to run PowerShell from within VMM.
Oh,
No, is it running? No, nothing happening there.
There we go. It is running.
Yeah.
Just give it some time.
All right, yeah, just. There we go. Bosh.
There we go.
There it is.
So just take a little bit of time to
sorry, I'm
trigger
too
that
impatient. I'm too impatient. Come on, VMM. So what you'll see is now we're creating that virtual machine, VMO2, and that's been done through PowerShell. So really easy, really straightforward. A good example of reusing that script that Virtual Machine Manager generates through the use of PowerShell in this case. So I think I'm good to go back to the slides at that point and take a look through some of this extra information. Because one of the features that is new in 2012 R2 is this feature known as Online Virtual Disk Resize. And that allows me to effectively extend or shrink a virtual hard disk that's attached to a running virtual machine. Now in the past, in 2012, this feature wasn't available. But in 2012 R2, this is something that's new and improved and available for you to use. So it gives me the option to, in the settings of the VM, so this is from the outside of the VM, right-click VM, Properties, extend the virtual disk file by, in this case, we've gone from a 30 gig VHDX file, let's say, extended it by 10 gig. Inside the guest OS, what you'll instantly see is an extra 10 gig of space. But we're not automatically going to provision the volume inside the VM for you. That's an extra job that the admin would have to do. But it could be on the fly without VM downtime. So you expand the volume within the guest at the Windows Server level, and you've now got 40 gig of space in this example. However, one feature that's unique to Hyper-V over our competitors in this space is the ability to go back the other way. So say, for instance, that I've shrunk the disk inside the guest operating system, so right-click that partition and said shrink. Whatever space I've been able to free up, because it can vary depending on your configuration within your guest, whatever space I've freed up, when it comes to Hyper-V on the outside, I can right-click, shrink that virtual disk, and it will shrink by the amount you freed up inside the guest. So we can grow and we can shrink that running virtual machine. Now, sticking with storage, we touched on Fibre Channel earlier on, we touched on iSCSI, and Simon also integrated our iSCSI array with Virtual Machine Manager on our Hyper-V hosts. But what about expanding the access to that Fibre Channel storage right through to the guest operating system? We've had pass-through disks for a while, the ability to pass through a physical LUN presented to the host, pass it through to a VM, and the VM uses it exclusively. But Virtual Fibre Channel presents a more native experience, a true Fibre Channel representation through to the guest operating system directly. So what we have in place is essentially virtual HBAs inside the guest operating system that connect to your physical HBAs that support NPIV and through to the Fibre Channel storage in that respect. So what that means from an administrator perspective is I manage a set of virtual worldwide node names and port names, and I present those to my storage admin perhaps, or if it's me, I can do all of this in VMM. I may say to my storage guy, look, here's my worldwide names for my new virtual machine I've just created. Here's the port and name details you need. Could you provision me a LUN? And that will only be unmasked to that particular VM. I don't need to expose it to the host first and then onto the VM. I just give the node names and the port names, and it will go direct to the virtual machine. So it's a hardware-based I/O path for direct Fibre Channel access through to the VM. And because it's Fibre Channel through to the VM, I can use my Fibre Channel storage array vendors' MPIO capabilities as well. You know, that device-specific module we talked about earlier, which is useful for optimizing the connection. So I can have up to 4 per VM, and it also supports live migration. So when we're initiating a live migration of a virtual machine, the storage traffic is typically traveling down a certain name set, a certain adapter within the Hyper-V host. And when you live migrate that virtual machine, we flick over the traffic to utilize the other set of names and addresses, so that when we do finally flick over from a migration perspective, there's no loss of traffic or data. So we're handling that seamless process, that seamless transition between Hyper-V hosts, utilizing live migration. So very, very powerful. And it's the right way to deploy virtual Fibre Channel if that's relevant to you in your environment. Now again, sticking with VM storage, we've looked at virtual disks and their new capabilities, the things like the virtual disk resize, for instance. Not only do our virtual disks now support up to 64 terabytes of capacity per virtual disk, which is huge, It was 32x the size of VMware before they updated for 5.5, and now it's 62 terabytes for VMware and 64 for Hyper-V, so just slightly ahead. But one of the new features we also introduced in 2012 and R2 is this quality of service. We saw it before on networks where we could say, I'd like to restrict the bandwidth, the network bandwidth for a VM to 100 meg or 500 meg or whatever it may be. But now we can do the same on a disk level, on a virtual disk level. So you'll see this particular virtual machine has got a couple of virtual disks, one for the OS, one for the data drive, let's say, perhaps where you're storing your databases maybe. And at the moment, that virtual disk is getting really hot. The number of IOPS going along that in and out of that particular virtual disk is hot. And it's putting an unfair tax on our storage array in respect of all of the other virtual machines that are starting to suffer. So with the storage quality of service, a quick setting in Hyper-V, I can turn that on and cap that particular virtual disk at a certain level of IOPS, meaning that VM is more controlled and it's not starving our IOPS capacity across all of our other VMs. So again, another powerful feature at the VM-specific layer. Now for an administrator, you often get into a situation where perhaps something has gone wrong and I really need a clone of that so I can give it to somebody else to troubleshoot while I work on the live copy. If that's the case, VM live cloning that was introduced in R2 could be very, very useful for you. It enables me to effectively do a live export of a running VM, a point-in-time snapshot, a merge of all of the details together and all of the data, so you can take away all of the files and folders that are necessary for that VM and give it to somebody else, and effectively a live clone while that original is still running. So that enables you to provide a rapid troubleshooting mechanism. So if Simon says to me, well, I need access to that VM to make some configuration changes. Well, no, it's in production at the moment. I'm not giving you access. I can clone him one, give it to him, and he can work on it in an isolated environment off the network. Because it is a clone. It would be identical on the network. So you want to move it into an isolated environment. So VMM can initiate that, or Hyper-V Manager. Once it's actually performed that clone into the target location, in Hyper-V Manager, you can import it in VMM, it will automatically choose where you want to place that clone. So again, VMM giving you a little bit more control and management. Now you'll see the word on the slide, checkpoints. VMM and Hyper-V have finally agreed on what we call a snapshot.
We've agreed.
Yeah, we've agreed, because for a long time, if you'd used Hyper-V Manager, you would have seen the word snapshots. If you'd used VMM, you would have seen the word checkpoint. And checkpoint is the way we've gone. So checkpoints now refer to taking a snap, a point-in-time checkpoint of the virtual machine. And that's what this live cloning utilizes as part of its process. And a more complete process if you are using Virtual Machine Manager. So to compare some of those virtual machine-related settings across Hyper-V and VMware, virtual CPUs, yeah, we saw this earlier, 64 virtual procs for Hyper-V, only 8 in the free vSphere hypervisor and the standard edition. When you get to Enterprise, it's 32 virtual procs per VM. When you get to Enterprise Plus, that's when you get the full 64. Big memory per virtual machine across the board, all supporting of dynamic memory. Big disk space, plenty of storage per virtual machine. Remember, we support up to 250 plus virtual disks per VM. Huge amount of storage if they're all 64 terabytes. I wouldn't like to pay for all of that storage, but it's possible. You can take advantage of it. The online virtual disk resize, both grow and shrink, is unique to Hyper-V. With VMware, it's a grow only and it's a little bit more fiddly. Storage quads, yeah, in the box, something that's restricted to some of the higher end editions of vSphere. And we go through a number of those capabilities across networking, performance networking, VMQ, SRIOV, those kind of features that we touched on later. They're all in Hyper-V. vSphere 5.5 did introduce SRIOV capabilities, but you can't live migrate the VM. You can't vMotion the VM if it's got SRIOV enabled. Hyper-V enables you to do that, which is mutually beneficial. You get the performance and you get the flexibility to move stuff around. So yeah, you've got these tables as a reference as well if you ever need to refer to them as well. So while we continue on a bit more of the virtual machine specific configuration, we touched on a bit of storage and networking there. But Linux, we had a few comments in the discussion panel a bit earlier on around Linux on Hyper-V. Linux is a fantastic platform to run on top of Hyper-V. Hyper-V has now got its drivers in many of the distributions now for the kernel. It's very high up in the root of the Linux kernel now, meaning when you deploy Linux, many of the distributions now onto a Hyper-V host, they've already got the integration components. If you're familiar with the VMware world, the VM tools, they've already got the drivers they need to be optimized on Hyper-V. So that's unlocking new levels of performance for Linux on Hyper-V and new features and functionality to be exposed as well. For instance, 64 virtual procs for Linux guests, virtual SCSI, utilizing the hot add and online resize capability. Remember the virtual disk resizing we touched on a few minutes ago. Full dynamic memory support for some of the distributions as well, meaning just like Windows can benefit from growing and shrinking its memory depending on the workload and a point of time, so can Linux. We also work closely to develop with the Linux community a backup capability that enables us to do a live running backup of a Linux workload, which if you're not aware, Linux doesn't have a VSS engine like a Windows guest does. So it's a little bit more tricky to take a live point-in-time backup of Linux. Whereas we've developed that solution now, so live backup is excellent for Linux guests on Hyper-V. Not just using Hyper-V and Windows Server backup that's built in, but also backup tools that trigger VSS and integrate with Hyper-V. And those deeper integration services mean we provide better troubleshooting information, crash dumps, just general better control and manageability of the Linux guest. And in terms of true support, I can ring Microsoft for Red Hat, SUSE, OpenSUSE, CentOS, Ubuntu. Oracle Linux is also supported on Hyper-V. So we're really working hard to bring more and more Linux distributions to the Hyper-V platform and give it best in breed for running virtualized on top of Hyper-V.
And this kind of best practice of enhancing our Linux integration is driven throughout our engineering teams as well. We actually hired a bunch of Linux open source experts to join Microsoft, join our core server and system center engineering teams. They're experts in the community, and we're actually checking in our integration components, other key things right into the Linux kernel. Ongoing future distributions, just booted up, we understand it, and Linux understands it's running inside a Hyper-V VM. So you're seeing a lot of investments, not just on the management layer, but throughout our internal engineering processes as well.
Correct. Now, I touched on before, very briefly, the Generation 2 virtual machine that was introduced in 2012 R2 and is exclusive to 2012 R2. And what we have on the slide is a breakdown of some of those benefits you get from Gen 2. Things like synthetic NIC PXE boot. You'll say, well, why is that relevant? Well, if you do PXE boot your virtual machines, or you want to do network-based deployment into a VM, which you can do, and that works fine, but in 2012 and prior, you needed to use what was known as the legacy network adapter to do the PXE boot, because pre-booting into Windows, there wasn't a device driver for the synthetic network adapter. But with 2012 R2 and this new Gen 2 VM, what that means is we can have the synthetic network adapter and utilize the PXE booting, which is a benefit certainly for VDI type deployments that use network booting to provision out those virtual machines very quickly. Citrix provisioning server of old would rely on that particular functionality, for instance. We can hot add CD and DVD drives to the virtual machine. We can already hot add virtual disks, so there's no difference there. Boot from virtual SCSI as opposed to the IDE, and we've got that UEFI firmware with secure boot, so helps to protect against pre-OS rootkits and reducing that attack surface as well. The boot will be slightly faster. You may see slightly improved performance, but this isn't like jumping to the next level of performance. That's not the aim of Gen 2. It's a future direction we're taking, and it's the first time we've introduced this into the release, but it's certainly something you should have on your radar as an option for some of those benefits we talked about before.
So we had an interesting question here. We have a customer that's running all server 2012 R2, both on the host and in the guest. Should they just deploy all their VMs as Gen 2 VMs?
Good question, yeah. It depends on the guest OS, because not all guest OSs are supported, but if you're just running 2012 R2...
With a supported guest OS, Windows 8.1, Server 2012 R2.
Correct, and I think Windows 8 and Windows Server 2012 are also supported guest OSs as well, so just one down level, but we can check, I'm pretty sure that's the case. One of the key caveats, I suppose, for Gen 2 is around Virtual Machine Manager support. Now, VMM does provide pretty comprehensive support of Gen 2 VMs from a life cycle. You saw I could have created a Gen 2 VM earlier on, so I could have gone through that same wizard that I went through for the create VM, but chosen Gen 2 stuff instead. Create, import, clone, migrate, all of that stuff works fine. However, it does support Gen 2 in regular templates, which are an accelerated way of speeding up the deployment of regular virtual machines through templating. But Gen 2 VMs are not supported for service templates, and we'll touch on what those are a bit later on. So at the moment, if service templates aren't something you necessarily use, and maybe you don't use VMM, then Gen 2 might be the viable option for you going forward. I mean, it's completely up to you, as long as you understand those benefits I talked about before.
And just another clarifying question. We said we can now boot from SCSI.
Yes.
We haven't removed IDE, right? People can still continue to use IDE.
In Gen 2, you only... in Gen 2, the virtual SCSI is the only disk controller in a Gen 2 VM. But that doesn't mean what's under the covers in your Hyper-V host has to be SCSI specifically. This is in the VM. In the VM in a Generation 1, you saw I could choose IDE to boot from. That was my only option. And SCSI disks could be attached for additional disks. In Generation 2, Virtual SCSI is the only device that virtual disks will attach to. But that doesn't necessarily reflect what you've got in your hosts. This is a VM-specific SCSI conversation. That makes sense?
Yep.
Right. So Gen 2 support in VMM, the key thing there is the lack of support in a service template today. And it would prevent, and if you look on the slide on the right-hand side here, if I try and deploy to an older host, i.e. one that's running 2012, it'll say, no can do. We cannot deploy a Gen 2 machine to a host that's not running Windows Server 2012 R2. It has to be running R2. Can't be running 2012 or earlier. That's not going to be applicable. Now, one of the other benefits that was introduced in 2012 R2, and Simon, you alluded to this before when you connected into your virtual machine with VM Connect, is this enhanced session mode, an enhanced VM Connect. So if you've ever been in a situation where you've got Hyper-V Manager on the screen, you've double-clicked a VM to open a console window. Normally, in the old mode, open quickly, and you wouldn't have copy and paste integration. You'd be lacking certain features and capabilities that we now present in this new enhanced VM Connect. So what it does is it pops me up that resolution slider, if you will, so I can adjust that independently. But it also brings benefits such as audio over the VM Connect. Using the VM bus as that transport, copy and paste between host and guest.
You can even print, right?
I guess so, yeah.
You certainly can,
yeah,
yes. We can connect to our printers from the VM to the host to the printer.
Yeah, I don't do a lot of that, but yeah, if that floats your boat, absolutely. But one of the key ones is remote desktop over VM bus. So even if that VM itself has lost connection to its VM network, i.e. usually that would be the only way to RDP into a VM would be over its network, we can RDP to that VM using the VM bus instead. So that gives us a new advantage in connectivity to perhaps a disconnected virtual machine. It's pretty useful if you want RDP in there.
I mean, personally, my favorite is the ability to copy and paste. You know, if you're building a lot of kind of VM templates for reusability, you want to inject content in them. Copy paste from the host to the guest OS, it's going to save you a lot of time in the long run.
Yep. And the final key capability that is unique to 2012 R2 is this activation. Now, if you've ever been in a situation where perhaps you've got to activate a lot of virtual machines, maybe you're a service provider, you've got to activate a lot of virtual machines, but the VMs don't necessarily have internet connectivity, they may be in a remote location. How do you activate all of those? Do you maintain a KMS? I mean, what is the process? It's convoluted, there's a lot of steps to go through. A KMS infrastructure takes time to set up. Individual product keys take time to enter, etc. However, with this new virtual machine activation, you activate your host, and it needs to be a Windows Server 2012 R2 data center host activated with your regular license key. So activate that one. But then, when you create new virtual machines, these are created and a automatic VM activation key that we actually publish on TechNet is readily available. That's injected into the build. Okay, so that's injected into your build of the VM. So whenever you deploy new VMs on this activated host, the key is already embedded within the VM, but it's a generic key across all of your VMs. And what happens is when the VM is started, they're activated against the host. So if you've got a validly licensed host, then the VMs will activate against that. You don't need to do any product key magic inside the VM. It will activate against that. Works with migration, moving VMs around. It's a generic key activated against a valid Hyper-V host, which is a blessing, so much so for service providers who are managing a large number of virtual workloads. The guest OS does activate and then won't recheck again for another 7 days or until the next guest reboot. Okay, so it's always confirming, am I on a legitimately licensed host or not? And if not, then you'll get prompts within the virtual machine. We enable reporting and tracking as part of this, and there's lots of documentation on TechNet on how to set this up. It's dead easy, but it can be very beneficial from certain scenarios. But it does require that data center host to be activated as well. But it's certainly very useful for VM activation. When we look at something like a VMware comparison here, the guest OS support. Yep, VMware have been providing Linux guest OS support for a while. You still need to VM tools for most of the distributions, whereas Hyper-V is pushing ahead with not requiring some of those capabilities. But the secure boot and the UEFI firmware for that extra level of security for virtual machines is something that's unique to Hyper-V. That is unique to Hyper-V in 2012 R2 and a Gen 2 virtual machine. Enhanced VM admin experience with the Gen 2s and automatic VM activation, unique to Hyper-V as well. You may not use some of these capabilities today, it may be something that's further down the line, but we're really pushing forward with really providing more than just running your virtual machines. We want to enhance the experience still further.
That's right. Well, we're going to move on now that we've configured our VMs, we've configured our host, to look at mobility, how we can move our VMs around. And when we're thinking of mobility, we are thinking about planned downtime. So this is things such as maintenance. I need to go evacuate a host, I'm going to replace a NIC, something like that. And that kind of differs from unplanned downtime, which is where we use clustering. An unplanned downtime is an unexpected crash. VM goes offline, we'll have to restart it, bring it back online. But if we know that we need to move that VM, and we have both the original host and the new host speaking to each other, this is where we can perform the live migration. But it's still critical to ensure that both of the hosts are running so that they can perform this end-to-end handoff. So live migration, what exactly happens here? Now, this is functionally equivalent to vMotion. We actually implement it slightly differently, but under the covers, the kind of key technology is the same here. You have your VHD, which is stored on the shared storage. Could be SMB, Fiber Channel, iSCSI, whatever. And then on the host, you have your running virtual machine. And this is the in-state memory. When we're doing a copy, what we're actually doing is copying the in-state memory from our first host over to our second host. We're essentially creating a clone of the VM on the second host. Now, while this is running, we got to keep in mind that our client is still connected. The application is still running. We're still changing pages in the actual memory of the computer. So even though we've taken this initial copy, it's important for us to track the changes. And we'll then do what we call a differential copy, where we go and take the information, then take what's changed, and push that across as well. And we do this recursively a couple of times as memory changes, modified memory changes, until we're essentially having two identical virtual machines running across these two different hosts. This is the point when we'll do a switchover. We will tell the virtual machine to redirect its traffic from this first host to the disk, to the second host to the disk, and then we'll also update our client connection by sending an ARP to the router that our client is connected to, updating the routing table so they no longer go into our first host, but the next time they enter our router, they get sent over to our second host. And from the perspective of our end user, no change. They don't care where the VM is running, and this is kind of this key concept of virtualization, hiding this underlying fabric. And you're going to hear us talk a little more about that later in the day as we start to think about moving virtual machines to the cloud, hybrid management, running your virtual machines on any type of data center.
Now, is a cluster required for the live migration, or is it something that...
Oh, great question. It used to be required for live migration. So back in 2008 R2, when we first introduced live migration, clustering was required. The boundaries was the scope of the cluster.
Yeah.
2012 and later, you no longer need the cluster for live migration. We can migrate between nodes of a cluster. We can go cluster to cluster, even standalone host to standalone host, or standalone host to cluster. So even though we say, our cluster can scale up to 64 nodes, with planned maintenance, it's really unlimited how large you can increase that boundary to. But that doesn't mean we need to forget about clustering altogether, because clustering still gives us that protection against the unplanned downtime as well. Now, in 2012, we continued to innovate on this. In fact, 2012 R2, we've gone and added a new enhancement, live migration with compression. Essentially, what we're doing is, as we're copying this data across this in-state memory from our first node to the second node, we're trying to be a little more intelligent with how we pass that data across. Instead of just sending it as raw information, we're actually going to go and compress it on the first host, send the compressed data to the second host, and then uncompress it back on the second host. So since we're passing less data, the transition time should be faster. we're able to do these live migrations much faster. And Matt, we might be showing a demo a little later as well on that, right?
Yep.
So stay tuned. We got a cool demo kind of showing you these different comparisons here. Now, we wanted to kind of continue to innovate with live migration as well. So we supported live migration over SMB with 2012. And what we're essentially doing with live migration over SMB is this is where we can go outside of the scope of a cluster, where we could go and copy a VM from a standalone host over to a standalone host. What we're really doing here is we are just copying the data from our first location to the second location. But what we're trying to do is be even more intelligent in 2012 R2 by adding support for RDMA. So RDMA stands for Remote Direct Memory Access. Essentially, it's a special type of networking adapter that allows us to better communicate between these two different hosts. The easiest way I like to talk about this is, we kind of do the traditional setup, right, where we're preparing our VMs for migration. But what we're able to do is, instead of sending the data from our first host to the second host, having it be processed in the kernel on the second host, then figuring out where in memory this VM should be placed, we get that information ahead of time. So as we're triggering this live migration, we know exactly where it's going to be placed in memory directly. So we're essentially able to bypass the kernel and the processing that happens on our second host to significantly speed up our migration times here.
Yeah, the key here is that the RDMA NIC is handling a lot of that processing of that traffic. It's using the SMB protocol that we talked about for storage earlier. It's just being processed by that RDMA NIC, which is incredibly fast. And if you want to put this in product terms, it would be like you having your dedicated live migration network using InfiniBand or iWarp or RDMA over Converged Ethernet, or RoCE as some people prefer to call it. So it's using those slightly more bespoke, certainly in the case of InfiniBand, slightly more bespoke connectivity between your host specifically for live migration.
Now, do you have the demo ready?
I can do, yeah.
Well, let's go take a look at the demo. While Matt pulls that up, I'll quickly kind of set up what we're showing you here. What we've set up is we configured 3 identical virtual machines. One of them is running on a host that has our traditional live migration. The second is running on a host that's going to be using live migration with compression. And then the third is on our special host, which has RDMA configured. And we're going to see kind of the trade-offs between fast, compressed, and then failover over RDMA.
Yeah.
Are you ready?
Yeah, I've got it, yeah. So it's underway. So what we've built here to help illustrate these migrations taking place simultaneously is this is a visual front end that's got PowerShell behind the scenes that's firing off at VMM and triggering these migrations and capturing the time it takes and so on. And this is a pair of hosts running 2012 Hyper-V, so not R2, and using the standard TCP/IP-based live migration. And this is an 8 gig of RAM SQL VM under load that's actually being transferred at this point. Now, as Simon said, this is the regular live migration. We're transferring those memory pages across the network using standard TCP/IP. But then that new platform we introduced, new compression mechanism we introduced in 2012 R2, enables us to essentially utilize the spare CPU cycles within our respective hosts. In this case, they are R2 to R2. And this is the new default for Windows Server 2012 R2. So you don't need to do anything to turn this on. It's on by default. If you haven't got enough spare CPU cycles, we won't use any. And the time taken to migrate will probably be very similar to this first one. It's using the standard TCP/IP, but it's compressing the data that it wants to move across the network. And what you'll see is the time it takes is significantly shorter than that of, and it's finished already, the same VM, 125 from 2012 to 2012, 32 seconds for the same VM.
Almost a third.
Yeah, not far off, yeah. But we could have stopped there, as Simon said. But we wanted to utilize and harness the SMB protocol, that storage protocol that's gone through so many improvements now in 2012 and R2, and utilize that for live migration and enhance it even further by using the RDMA connectivity. So just to clarify, you can use live migration over SMB with or without RDMA capable hardware. If you've got RDMA capable hardware like InfiniBand, RoCE or iWarp, then it's going to accelerate even further. If you're not, then it's just going to utilize regular gigabit Ethernet or 10 gigabit Ethernet.
Well, you keep teasing us. Let's see it in action here.
Here we go, ready. So with RDMA, remember it's offloading a lot to the actual physical networking hardware. It's using the SMB protocol, it's the same VM, 8 gig of RAM, utilizing quite a heavy workload, running SQL Server. Boom, there you go. 125, down to 10 seconds.
That's about 9 times faster then.
Significantly faster, yeah. We've actually done tests in our lab environment where we've utilized some of the RDMA InfiniBand connectivity between the hosts as the live migration network specifically. And what we found is that the bottleneck of migration, the speed, the thing that held us back the most, wasn't the disk, it wasn't the processor, it wasn't the network card, it was the speed of the RAM, the physical memory in the device, in the host. We couldn't transfer the RAM fast enough. It just couldn't keep up. It's so fast, the transfer speed, just phenomenal. And that's the power of what you can deliver with RDMA-enabled live migration.
Very nice. Well, we wanted to kind of just think about not just migration of our VMs, but other things you may need to move around for maintenance as well, such as the virtual hard disk for that virtual machine. What happens when you need to do maintenance on the SAN? Well, we introduced storage live migration, kind of equivalent to storage vMotion, that allows you to keep a running virtual machine online and transfer that back-end VHD or VHDX file from one location over to another. Let's take a quick look how this works in our graphics here. So right now you can see that my host is running on a SAN, and this could even be direct attached storage. This could be, pretty flexible with what type of base storage you have. And this is then what allows us to do this standalone host to standalone host migration with our direct attached storage. What we're essentially doing here is we're going to create a connection between our storage devices and copy the data over. So create a clone of that VHD. Now keep in mind, things are changing, right? It's once again a live system. So as changes happen on the first disk, we're making sure those get replicated to the second disk. Now, once we've got identically configured disks, we're going to simultaneously push the data to both disks. So a change happens from the VM, we write to both disks. We then cut away from the first disk, continue right into the second disk, and then clean up the original VHD, freeing up that storage space and allowing you to do maintenance. So great capability here if you need to do patching on the patching on the storage, do updates to the storage with zero downtime to your running virtual machines. But now we're going to combine the best of everything here. Our live migration over SMB, our storage live migration, do them at the same time, and we do what we call a shared nothing live migration. We're essentially moving the running virtual machine first, and then we're moving the running storage, but as a single unified operation, meaning that you start from anywhere, move your VMs to anywhere, so long as you have permission and connectivity throughout that environment. So let's go ahead and actually take a look at this in action and see what this looks like. I'm going to switch back to my demo system. And here we see that we have our 2 virtual machines, which Matt has created. Now, due to the limitations of our virtualized environment, we can't actually start these VMs. We can't run a VM from within a VM, this nested virtualization discussion we've had. So these VMs are offline, but nevertheless, we can still kind of walk you through the process of how to migrate them. If they were running, they were live, it would be the exact same experience. So for us to go and deploy one of these VMs, we select the first VM, and then we just say migrate virtual machine. It's going to go and launch our migration wizard. And we can see from our ratings explanation that this host is going to be a pretty good candidate for placement. Now we know this virtual machine has to be highly available, no problem, so it's going to recommend these 2 cluster nodes. Now anytime you see a star-rated recommendation, you can actually click on the ratings explanation tab and it's going to give you information as far as why this is supported or why this is not supported. And in this case, I meet all of my goals. So I'm going to click Next, review the information, and again, I can go pull up one of these scripts if I want. So if I wanted to do a bulk live migration, I could run a script, or we can just multi-select. So a lot of different options with how we're deploying this. I click Move, we're moving our first VM, then we're going to run some pre-checks. Now, pre-checks is another enhancement that we've added on clusters in 2012 R2. Rather than move a VM from one cluster node to another and have it non-functional on the second cluster node, before we actually start that live migration process, we check that the virtual networks are online, that the cluster service is running on the destination host. So we're trying to just build a little bit of resiliency before we trigger this live migration to make sure we don't live migrate to a bad host or a host that has a disconnected network. Now, second type of migration I'm going to show you here is our storage live migration. So going through kind of a similar process, select the VM, we'll say migrate the storage. And this gives me a couple of options, specifically where exactly do I want to go and move this VM. I can automatically place all VHDs on the same path, or be able to place each of the VHDs that this may be using individually. We'll just keep this simple here. And by default, you're going to see that we've got our file share configured. So we're going to move this to file share storage. So, oops, select, let me
move it somewhere else.
Move the other one, here we go. Our storage is already running there. So we'll go move it over to file share 2, VM share 2, click OK. So the problem was I was trying to move it to the storage. It was already at. So we keep our VM in the same place, and then in the background we're moving our storage from the first location over to the second location. There would be no downtime for our virtual machines.
If it was running.
If it was running, of course.
Exactly, yeah.
So as you kind of see, looking through these different options here, you do have these abilities to go and really try to optimize how you're going to move your VM, how you're going to place it. And even within here, you'll see different types of transfer types that it's going to run.
So if I wanted to, we talked before about networks, and we talked about how I turn those settings on, compression and those kind of things. Where do I go and do that?
That is a great question.
It's important to know how to change those, I think.
Yeah, great question. So let's actually go to our VMs and services view, select our cluster here, and take a look at the properties of the cluster. Oh, sorry, of the particular host. And this is where we'll go and take a view of the status, make sure everything we need is running. Look at the hardware that this host is using, so the local disks, the networking, the virtual networks it's connected to. See who can access this host. Then as we take a look at reserves, we are going to inherit all of these reserves from the parent group. But let's focus on the migration here. Here's our different migration settings. And you'll notice here that we can specify a maximum number of storage live migrations and a maximum number of traditional live migrations. Now, one question we always get asked, Matt, is what's the maximum number of live migrations we support?
Good question. So the actual answer is it's unlimited. I don't know what the UI supports. I think it's like 999999999.
Oh, that's pretty high.
But in realistic terms, it just depends. It depends on your environment. 4 for gigabit simultaneous and 8 for 10 gig is a good number to start with. But you may find that your environment responds better with slightly less or slightly more. It's entirely up to you. We don't necessarily say one is definitely right for you versus the other. So that would be a decision you make in your environment. But flexibility-wise, you can tweak them to whatever you want.
Absolutely. What we really find, we kind of find that sweet spot between 4 and 8. Now, when you think about when you're doing a live migration, right, you may think, well, if I do 100 live migrations at once, things are going to move faster. Actually, that's not quite true. There's kind of a certain sweet spot that you'll hit as you plan how many live migrations you're doing. And the reason why is because we do these differential copies of the memory. So let's say I'm just migrated 2 virtual machines at once. We do that initial migration. While that's happening, we keep track of the changes. So let's say it takes me 2 minutes to migrate 2. Keep track of the changes, maybe another minute to add that final part. So 3 minutes for our 2 VMs. If I migrated 4 VMs at once, they're going to go slower, right? I only have that much network bandwidth, so they're going to go half the speed as those 2. So maybe it takes me 4 minutes to do that initial live migration. The challenge we have is there's more memory that's changed in that 4 minutes than you had changed in the 2 minutes. So that secondary incremental live migration means you need to copy more data. That third live migration, more data, more data. So you kind of reach this spot where if you're migrating too many VMs at once, you have to do so many recursive additional live migrations to move those additional memory pages over. You actually put an inefficiency there. So as Matt said, we don't have an official recommendation. We kind of find the sweet spot to be 4 to 8. It really is going to come down to your testing. And the biggest thing that impacts that live migration speed is active memory pages changing. So if you're migrating like a Windows 8 VM that's using client operating system, nothing's really changing. Go through 100 of them across at once. It won't make that much of a difference. Let's say you have a VM that's running a SQL database, lots of in-state memory that's changing. After that initial copy, we're still going to have to do a pretty big secondary copy. So this is why there's no specific best practice. It really is going to depend on what you're running inside those virtual machines. Now back to the screen, here's the options that we can configure to show live migration over compression or traditional live migration. And we also have the ability to go and change which of our subnets we want to use for live migration as well. So I can say, here's my preferred subnet. In this case, I want to use my 15.15 subnet, but we could really reorder them and use them as we need. Now, as we wrap up our live migration here, let's take a quick look at how we compare to VMware. Oh, but look at that. I missed one of the most important features as well, live migration upgrades. Now, upgrading our host, this is important, right? We want customers to use the latest version, 2012 R2. But we want to make it simple to do an upgrade. So we now have the ability to live migrate your VMs from 2012 hosts to 2012 R2 hosts with no downtime. So as you're upgrading that physical infrastructure, zero downtime to your running virtual machines that are on top of that. So taking a look at how VMware compares with our live migration. Well, with vMotion, they led the industry coming out with this first, something that we've certainly adapted and included. But we've now taken charge and really tried to enhance this further with live migration with compression and live migration over RDMA. Additionally, Hyper-V doesn't place limitations on the number of simultaneous live migrations. We could support it if it makes sense for your workload. Then with our other kind of live migration enhancements like shared nothing live migration, Hyper-V innovated this first, released it first, but being such a popular feature, we're seeing the rest of the industry trying to replicate a similar functionality as well. Well, Matt, we have just about finished up our section on live migration. I'm going to turn it back over to you as we're going to start to talk about replication and protection.
Yes. So what we've talked about there is moving stuff around in a planned fashion. We also talked about clustering before, which is an unplanned scenario typically. But that only covers you typically for people in clustering. It only covers them locally. What if you want to deploy a solution that gives you more business continuity and a DR option geographically? Maybe you want to replicate from one side of the US to another, from one continent to another. How can you provide that flexibly with a solution that's low cost, affordable, and easy to automate? And that's where some of the solutions we're going to talk about now really come in. And what we're going to first talk about is a feature known as Hyper-V Replica. Now, Hyper-V Replica is a Hyper-V enabled feature. Unfortunately, it's not something that VMM can configure today, so when we do some demo, we're actually going to duck into the Hyper-V Manager interface and configure that, but it doesn't take very long. And what this does is effectively provide an affordable in-box business continuity and DR solution. And what essentially Replica is, you've got a primary site in this case, using Hyper-V hosts from one manufacturer, insert your server vendor here, and you're using, in this case, in this example, block storage, using cluster shared volumes that Simon walked us through earlier. Again, insert your storage vendor here. It just doesn't matter. On the primary site, we enable Hyper-V Replica, and an initial replica is taken. That initial replica essentially eventually checkpoints or snapshots the VM and copies that data across the network. So that's a bulk copy at that point. You can choose to replicate immediately, do it a bit later on at a certain time, or you can even send it via a USB media, for instance. Or you can even use a backup that's existing on the secondary site as your starting point for the replica. It's up to you, pretty flexible. But that initial replica starts. And what you'll notice is our second site, these servers could be from another vendor, completely different from your primary. And the storage, in this case, we're using SMB-based file server storage on perhaps storage spaces. So again, flexibility. What I'm trying to get across there is it's agnostic of both servers and storage hardware. It just doesn't matter. So once we've done the initial replica, then we send the delta changes. Just the changes on a frequency that you define. The choices for that replication frequency are 5 minutes, which was the old mechanism in 2012. That's still there in 2012 R2. Then the second option is down to 30 seconds. So every 30 seconds we're sending the deltas, or as high as every 15 minutes. So 30 seconds is near synchronous replication without the cost of synchronous replication technology. So it's pretty flexible for organizations to achieve a great level of resilience for those workloads. And once that's finished, upon failure, VMs can be started on a second site, and that can be triggered through Hyper-V Replica. Alternatively, we can do a planned failure, so it doesn't actually need to have failed on the primary for us to transfer over to start running on the secondary. We've got that flexibility. It handles live migration. We don't need any other VM replication technology. And as we'll see shortly, it's really easy to configure. In fact, is it worth ducking into a demo now, or shall we? Well, yeah, we'll do it now. Come on, let's do it. So let me go into my environment. I was just in VMM before, just fiddling around with some of the stuff here. So I'll minimize this. I'll minimize our PowerShell script for the time being. And what I'm going to do, because there's a little bit of setup that we've got to go through to configure this first, because we've got a cluster within our environment. We've got a cluster that we saw us build earlier on. Now that particular cluster, if I bring up Cluster Manager, failover Cluster Manager, there's a little bit of a feature that we need to enable within this environment. Let me just bring this up. Let me connect to a cluster. What was your cluster called?
Oh, good question. Contoso-cluster, maybe?
Yeah, catchy. Could just browse, I suppose. So that brings that in. Okay.
Perfect.
There we go. So we've got our cluster. We've got our roles. We've got our nodes. So our roles are things that are highly available, and those are the virtual machines we created earlier. Our nodes, as the name would suggest, are our cluster nodes. And we've got some storage as well, in this case disks and so on. We've got our cluster networks as well that are common across our cluster. But that doesn't matter for the time being. One of the things that I want to enable, in fact, firstly, let me turn on Replica for a standalone server. This might make a little bit more sense and bridge the gap a little bit easier. So we've been working with 2 Hyper-V hosts so far, Hyper-V 01, Hyper-V 02. Yeah? Well, Hyper-V is actually also enabled on our VMM server because we wanted to keep it hidden for now so we could bring it in at this point. So I'm going to enable Hyper-V Replica on this particular machine. So you see replication configuration, enable this computer as a replica server. We're going to use HTTP for the traffic over a specific port. I'm going to allow replication from any authenticated server. And in terms of where am I going to store the particular virtual disks that are replicated and VMs, I'm just going to choose to store them on E drive. That'll be fine there. So essentially what I'm set up for one of my Hyper-V hosts is allowing replication, turning it on, choosing a specific port that it's going to use for the data to be sent across the network, and I can click apply. It's going to give me a notice saying, well, make sure the firewall is ready for this. I've done that already, so I don't need to worry, and then click OK. Now that would be how you enable it for a standalone Hyper-V host. Okay?
So right now we've just turned it on for one. So this single host by itself isn't really going to have much functionality. What you're now going to do is configure a replication pair, essentially, right?
Yeah,
so one server to another server.
Yeah, at this stage, that VMM server, this one here, VMM01, has got replication turned on. So it could replicate somewhere else, or it could receive replication at this point. That's all we've done. But it's got no VMs of its own, so it can't replicate to something at this point. But we've also got another entity within our environment, this cluster. Now you'll say, well, why don't you just click each node in the cluster and do the same thing? Enable Hyper-V Replica on each one. Well, yeah, I could do that, but that wouldn't be the right way to do it for a cluster. For a cluster, you have to enable something called the Hyper-V Replica broker. And to do that, I'm going to right-click, configure role, and that's going to allow me to configure a cluster-level Hyper-V Replica setting. And you'll see it here.
Now, essentially what the Hyper-V Replica broker is, it's the replication engine made clustered. So when we think, hey, you've put these virtual machines on top of a cluster, you're probably going to want to make those VMs replicate, right? Or if you are replicating them, you want to make sure that replication always happens. You said these VMs are important, I want to use replication. So what we've done is we have made Hyper-V Replica itself highly available. And so this Hyper-V Replica broker functions like a VM or anything else on the cluster. It's a single instance, and it will move between the different nodes of the cluster as a node crashes. So your replication engine might be on node 1. If node 1 crashes, replication logic fails over to another node, so we ensure replication won't be missed. But kind of the biggest change that has caused is how a lot of people are configuring their multi-site disaster recovery topologies. In the past, you would have a single cluster stretched across both sites. Node 1 and node 2, node 3, node 4 have some type of storage replication between. Now that we have this cluster as our own replication engine, we're actually going to set up cluster 1 at site 1, cluster 2 at site 2, and we're actually replicating from one cluster to the other cluster. So this is an important understanding. When we have the replica broker, we do not replicate between nodes of a single cluster. we can replicate cluster to cluster, standalone to standalone, standalone to cluster. But again, not within a single cluster, because that replication engine is highly available.
Yeah, so what we're saying there is you wouldn't replicate from Hyper-V 01 to Hyper-V 02 if they were part of the same cluster. However, what we're doing here on the screen, I've got the Hyper-V Replica broker that I want to enable. Remember, on each of these individual Hyper-V hosts, I've done no Hyper-V Replica configuration at this point. They are as vanilla as the ones that I just did for VMM a few minutes ago. So Hyper-V Replica broker is going to take control of all of the configuration. So I'll go next. I'll give it a name. I've given it HVRB, and then I've given it an IP address on the network. So this is essentially like a DNS record for the cluster from a Hyper-V Replica perspective. So when I'm replicating from a standalone host to a cluster, I don't give the name, the DNS name of one of the cluster nodes. I give the DNS name of the Hyper-V Replica broker. And from that point forward, Hyper-V Replica broker orchestrates where in the cluster that information is going to be replicated to. And this will make sense a bit more as we go forward. So I'll click Next. Confirmation, that'll come through. Yeah, that's fine. We're going to configure this high availability for the broker. Next. And just like that, done. So now we have a Hyper-V Replica broker. I still need to configure the replication settings. So I'll go Finish. I'll go to Roles. And you'll see now we've got something coming online. It's now running. I'll right-click, Replication Settings, and this wizard should look familiar. Here it is, except this time it's on a cluster level. Enable the cluster as a replica server. So think of the cluster as one big replication entity. Either you replicate out from the cluster on the whole, or you replicate into the cluster. You don't replicate into a specific node in the cluster, you replicate into the cluster. So I'll choose Kerberos, as I chose before. I'm going to allow any replication from any authenticated server, and I need to choose a location. In this case, I'm going to browse. I'm going to go //. I'm going to choose FS01 / VM share 1. So I'm going to use my SMB share as the repository here. In fact, I'll choose VM share 2, I think. It's probably better. Yeah, VM share 2. There we go. Oh no, it's chosen 1. There we go. Apply. So now this is the same as me going to every individual Hyper-V server as part of this cluster and turning this on. It does it all for me across the cluster, which is great. So go OK. Now, what is the next step? What should we do? We've set up replication. We may as well replicate a virtual machine.
Let's do it.
Yeah, here we go. So I'm going to select a particular virtual machine here. I'm going to select VM01. I'm going to right-click, Replication, Enable Replication. Remember, all of this can be triggered through PowerShell as well. It's just I'll do it through the GUI. It's a bit more exciting. Well, for me anyway. I don't know about you, but I'll go next. Where am I replicating to? This is this first question. So I'm going to replicate to SCVMM01, which is one of our machines within our environment. I'll just check that's the right name. Yep, it is. There we go. So this is me replicating from a cluster out to a standalone node. If this was the other way around and I was doing this wizard from VMM, what would I enter here? I would enter HVRB, the Hyper-V Replica broker name that I entered a bit earlier on. So I'll go replica server is VMM01. It's automatically grayed out this because it knows that I've only enabled for the cluster port 80. It only knows that VMM has enabled port 80, so that's what I can use. That's what's consistent between us. I'm going to compress the data. What am I going to replicate for this VM? Well, just a single virtual disk, but I may choose to add others or remove others if I've got a lot of virtual disks per VM. I'll go next. How often? 30 seconds, 5 minutes, or 15? I'll just choose 5 minutes for now. Do I want to configure any additional recovery points? And what that means is additional points in time that I can roll back to, because by default, we're only going to be able to roll back to the latest point in time. So in the event of a failover, what you're going to fail over to is literally the latest point. However, I could keep up to 24 hourly points that I could roll back to as well. Because don't forget, if something goes wrong in a virtual machine, you're replicating that wrongness to somewhere else, if that's a correct term. Possibly not. Whereas if you keep additional recovery points, yes, it will use more disk space, but you will have other points in time that you can go back to, kind of like a snapshot. Additionally, I can also use VSS to quiesce the applications within the guest operating systems as well. That's another option that I've got. I'm going to use the latest. How am I going to get that initial disk space over the network? Via the network initially, send it via external media, use an existing VM that's been perhaps backed up and restored on the second site, or I can send it via the network and start it at 4 p.m. today or at some stage later, whatever it may be.
So you're saying, though, what we could do if maybe we have a branch office that doesn't have good network connectivity, when we first configure this, instead of having to send 100 gigabytes through the network, we could put it on media, take it to literally drive to our other data center, load it up from there, or put
cycle.
it in the mail.
Yeah, or cycle. Yeah. If you're more eco-friendly, yeah, absolutely. You could do any of that, yeah. Or if somebody's already got a copy over there, they could use that as and we could effectively replicate onto it. But yeah, you've got it. You've hit the nail on the head. So we'll go next. We're going to configure a replication now. It's going to start immediately. Here we go, and finish. All being well. Enabling. Bish, bash, bosh. There we go. Enabled successfully. So while that's enabling, and while that initial replica of that 4 meg size is going across the network, which might not take very long, let's look at the settings. Because just by doing this, some of the extra settings for this virtual machine are now exposed. Remember before when we created this VM, and this is a bit of a segue, remember when we created that VM and we attached the Contoso standard port, the port classification, and when we set up that port classification, we said we'd put on maximum bandwidth of 100 meg. Now you can see bandwidth management for this particular virtual NIC enabled 100 meg. So VMM has applied that as part of the policy. If I expand this out, look at this failover TCP/IP option. I can specify the network settings for this VM, so when it fails over to site 2, it injects those particular network settings for this VM, because it might be different on your other site. It might not be the same as what you need it to have over this side. And we can also specify a network that if you want to test replication and failover, so you want to bring stuff up on a second site but leave the production stuff running, you can do that, and you would specify a test network that would enable you to isolate that. Because if you start something up on the secondary site and the primary is still running, you're going to get 2 versions of the same thing on the network, which would be bad. So this test failover helps you to do that, which is pretty useful. So we'll cancel out of there, and we'll look at some of the options that we can perform as part of this particular setting. So I'm going to go to, we've finished the replication, we've replicated over. I'm going to bring up settings here. In fact, let me go back to cluster.
Now, while you go ahead and do that, one of the most common questions I get asked is, what can I replicate? Can I only replicate VMs? Well, yes, this is an application level replication, right? If you're replicating SQL from bare metal, probably go use that SQL replication technology. But don't forget, we support almost anything inside that VM. So while, yeah, we're not replicating your key application server directly, we're replicating the VM that contains that. So as long as you're in a highly virtualized environment, we're agnostic of what's running in that VM. We're replicating the VHD, what's saved on the file. So we're going to make sure that whatever that application is, if it's supported in Hyper-V, it's supported inside the Hyper-V replica.
Yep. With the exception of today of Exchange and SharePoint. Yep. So those two aren't. SQL is supported, and there's guidance online as to what you need to do. SQL clusters aren't supported, but SQL Server standalone is supported with Hyper-V Replica. But there's a few little things you've got to adjust, and that's documented on a KB article. But if we just explore some of the settings for replication now in the environment, you'll see that I've right-clicked VM01, replication. I've got planned failover, i.e. I know that there's a disaster coming. I'm going to plan the failover now and instigate it and start off that failover over onto the target host. I can pause the replication, I can remove it, or I can look at the health. And we'll see here, everything's good at this point. It's going from primary, Hyper-V02, somewhere in the cluster, to SCVM-M01, that's the target node. That's the size, no latencies so far, everything's been fine, and everything's been replicated successfully so far. So that's the replication health. If I go over to, let's say, the disaster site, VMM01, you'll see this has magically appeared from nowhere. And if I look at replication here, I have some extra options because it knows we're on the target site here. So I don't have planned failover, I just have failover, i.e. you've lost the primary site, what do you want to do? Do you want to initiate a failover or test? I've got this other option, extend replication. Now I'm going to talk about that in a minute in the slides. I can also remove and view the health. But it's as easy as that. Hyper-V Replica is an absolutely, completely straightforward thing to set up, and it can be automated through PowerShell as well. So people find that they can build quite advanced failover scenarios of which order VMs will fail over, how that will all be orchestrated through PowerShell without the need for any additional third-party or extra technology or products, even without System Center. Because I've done that whole demonstration there without VMM. So it's something to be aware of. VMM does understand Replica, but it wouldn't allow me to configure it in that way that I've just done. So I mentioned before Hyper-V Replica and extended replication. I just saw it in the wizard there. But what does that mean? Well, as we see on the slides here, we've got our replication configured from primary to secondary. We're done. We've set that up. Everything's happening. Great. However, extended replication allows me to replicate the replica to a third site. So think of it like A to B is what we just set up. Now I could set up B to C. So it would be taking that virtual disk and the virtual machine and replicating it not just once, but twice to another location.
Now, I've heard of a lot of customers that are in these dense metro areas, like financial companies in New York City, where they need to use this extended replication because both of their sites are on the same power grid. You know, they have Site A in Manhattan, Site B over in Hoboken across the river. But if you lose that whole region, you're out. So this extended replication gives you that even higher availability. Do kind of the local failover first, or city failover first, then you're going to do that extended replication, push it out to some other part of the country.
Exactly. I mean, you could have, for instance, your two data centers which are located on really high-end pipes, perhaps, in between the two. If you're just across the river, for instance, you may have really high-end connections between the two, which support 30-second replication, so really fast, near synchronous. But then your second site, B in this case, your third site could be on the West Coast. You know, it could be completely the other side of the country, and that might just do every 5 or every 15 minutes, depending on your links. Whichever one you choose, you can't do 30 seconds for the extended replication, just 5 minutes or 15, but you've got a bit of flexibility there. But it's essentially chaining replication, so one VM gets replicated from A to B, and then on again from B to C. So that frequency can differ as well, so you could have 30 seconds primary, and then 5 or 15 minutes from secondary to tertiary. That's up to you. But that'll be really useful if you're, for instance, say an SMB, or you're replicating to a service provider, and that service provider wants to replicate to their own DR site. You know, so you've got that additional level of security for your workload. But to see this visually, we've got our primary and our secondary. Everything's set up there. We then enable replication on the first replica we made, initiate that replication across to the third site, and look at this time we're using DAS storage. So we've gone from certain vendor of servers and block storage to certain vendor of servers and file-based storage, and now we're replicating to a different vendor of servers, this time with DAS storage. It doesn't get more flexible than that, and that is real flexible for Hyper-V Replica. Doesn't matter on the networking switches, doesn't matter on your server or storage vendor, completely agnostic. But I mentioned before you could automate a lot of that with PowerShell, but what if you don't want to? What if you prefer a service that's like an eye in the sky, if you will, looking at your different sites, looking down from above, and can help you orchestrate the failover of lots of VMs simultaneously, orchestrated in a managed fashion from one site to another, using even a mobile device that supports a web browser. And that's the flexibility that something like Hyper-V Recovery Manager provides us. And this is an Azure-based service, a Windows Azure-based service that runs in Azure, but your replication of your data is not to and from Azure. Your replication, as the diagram shows here, still takes place between your data centers. We're replicating from your Hyper-V host between your respective data centers. We fail over at the cloud level within Virtual Machine Manager, so failing over your VMs from your site to another one of your sites or a service provider. All the information that is stored in Windows Azure is just the connectivity to your VMM, the metadata. So it knows where stuff is and what needs to fail over from site to site. It's just a communication channel. No data is replicated up into Windows Azure for those concerned with their data locations, for instance. It helps me to set up Replica at scale across lots of different virtual machines, rather than do it on a per VM basis like you just saw me perform through the wizard there. So it provides replication, it uses Replica as the engine, but Hyper-V Recovery Manager orchestrates the setup. And it allows me to define things like plans, like a series of steps. So for instance, you may want a group of VMs to fail over first. Then you may want to run a custom script that you've written that you upload into Hyper-V Recovery Manager, and it executes that as the next step. Then it waits for somebody manual to do something like flick a switch. Then it fails over the next set of VMs in a certain order. It orchestrates all of that for planned, unplanned, and even testing failover between sites.
Got a good question here. Does the free Microsoft Hyper-V server support Replica?
Good question. I'm afraid, yes, it does. Yeah. Yes, it does. Yeah, it has all of that capability. We're using those Hyper-V servers for our cluster nodes, so that's exactly what we've demonstrated, absolutely. It integrates with scripts, as we said, this Hyper-V Recovery Manager. It is a paid-for service, so it's not free, but you can sign up and test it. If you've got MSDN, a subscription, you can utilize that as part of your testing and trying it out online as well. So it's very useful and certainly worth a look if you've got a large number of VMs you want to fail over. For a service provider, it's also an additional revenue stream as well to help customers migrate their workloads without complex setup. All you need, VMM on one site, VMM on another, they talk to Azure, and from that point forward, you're good to go. Azure does not have your data replicated up into it. That's not a scenario that's in Hyper-V Recovery Manager. So that kind of brings us to the end of our VM replication section. A quick comparison though. Hyper-V does have an incremental backup solution built in. We didn't talk about it today, but Windows Server Backup is a built-in piece of functionality that can back up VMs on a host-by-host basis. But really, Hyper-V Replica provides a lot more compelling capability across that replication, even locally between two geographically close sites or far away on different continents even. When we start to compare some of the replication capabilities between our replication, Hyper-V Replica, and vSphere replication, what you'll find is there's quite a few differences. One is inbox with the hypervisor. One is a virtual appliance that runs on top. They're both asynchronous, but Hyper-V Replica offers a lot more flexibility and lower RTOs, so they're down to 30 seconds. We support that A to B to C replication, which is something not supported by the software-based vSphere replication. Note, this isn't comparing SRM, Site Recovery Manager, if you're thinking, well, SRM delivers all of that capability. Absolutely, of course it does. But this isn't comparing that, nor is it comparing Hyper-V Recovery Manager. Just that core Hyper-V Replica engine. Now, in terms of that point-in-time recovery, it's actually 24 points, and I believe vSphere replication does actually support 24 points as well in their newest release. It's a mistake on the slide there. But look at this orchestration. If you want to automate that, maybe you've got 50 VMs you want to orchestrate. I can use PowerShell, or I could use Hyper-V Recovery Manager, or I could use another System Center tool like Orchestrator. Notice it's or. I could use one of those if I want to. Whereas with VMware, you cannot. With VMware, you cannot actually replicate and automate that without SRM. You cannot do that. SRM is the only way that you can automate a lot of this failover with vSphere replication. Okay, so we offer that leg up into automating that type of scenario. So that brings us to the end of our replicating VMs. So it's about time we pop back to networking. It's been at least an hour or so since we talked about networking.
We love our networking here.
Yeah, we do, absolutely. And network virtualization. Now, because we're talking about VMs, network virtualization is really all about VMs. And it enables us to isolate workloads on top of a virtualized infrastructure. So let's have a look at what that looks like through the slides. Because what's it aiming to solve? Well, think about your environment today. If you wanted to isolate VMs from one another, all on the same virtual machine network, what would you do? You'd use VLANs for most part. And that's fine when you've got a handful of VLANs to manage. You manage them at the VNIC level for each virtual machine, and then you also manage them at the host vSwitch and also the physical network switch layer to ensure that tagged packets are going to get to the relevant locations they need to. But there's a lot of configuration there, especially if you've got multiple physical switches, aggregation switches, top-of-rack switches, and so on. Because one change, one additional VLAN tag that you need to implement could be a change in 6, 7, 8, 9 places, depending on how automated and controlled your network infrastructure is. So that VLAN poses, especially in large environments, a big headache. And not all switches support that many VLANs. It may cap out at 1,000, it may be even less. VLANs in general can only go to 4,095, which for some larger service providers with thousands of customers, that's becoming a bottleneck. But network virtualization solves that problem. It also gives us flexibility to move VMs around because we're simplifying the physical network fabric and building these VM networks on top. And because the whole of the hypervisor layer of our virtualization infrastructure knows and understands this network virtualization, VMs can float anywhere. They don't need to be tied to a specific rack in the data center where we know we've configured certain VLAN configurations. Because we're not using VLANs anymore, these VMs can just float all over the place, which is very flexible for resource utilization. And best of all, it's integrated seamlessly. Imagine you're a service provider. You've got a customer, a new SMB customer has come on board, said, I want you to host my 20 VMs. All of my VMs currently use 10.10.10.x as the IP address scheme. Okay, here's your VMs. Service provider, difficult conversation number one is, well, we've run out of VLANs, we're going to have to change your IP address scheme or some words to that effect. That's not an ideal conversation to fit in with my service provider model. With network virtualization, I can say, well, actually, I can just create a new VM network that contains your 10.10.10 network, and everything will be fine. They'll be isolated from all of the other customers on my fabric, even if all of those other customers have got 10.10.10.x as their network IP address scheme. Just doesn't matter. So if we illustrate some of that and some of the key concepts, your physical hosts, your Hyper-V hosts, have to be routable on the network. They have to be able to communicate with one another. And that routable network consists of a number of provider addresses. These are unique IP addresses that the hosts maintain on the network. So as long as they're routable across the network, that's the key thing that we need. But then on top, we build what are known as VM networks. Imagine that if it makes it easier, think about if you would define a VLAN. Blue network could be VLAN 2, red network could be VLAN 6, if that helps you separate it. But the key point is we're not using VLANs. We're just isolating them with network virtualization. We're isolating blue VMs from red VMs. And inside each of those VMs, the guest OS IP address is what's called the customer address. That's the address, the IP address that is inside the guest OS. And Hyper-V and VMM combine to maintain a relationship and understanding of what network, blue network, red network, whatever it may be, that the VM is part of, the provider address, i.e. the host that that VM is currently running on, and the customer address, the guest OS IP address. So for instance, we know that in this case, two of the starred ones here, blue with the customer address of 10.10.10.12 is running on this particular middle host. However, we also see that red 10.10.10.12 is also running on that middle host. How do they not conflict? They've got exactly the same IP address. Well, they're in different VM networks, so they're completely isolated from one another. And VMM maintains this central policy table and dishes elements of this table out to the Hyper-V host as and when required, so they can maintain their own view of their slice of the table as they need it. So they can understand how to route traffic through the network. And in terms of how it isolates and how it encapsulates traffic, it is a tunneling encapsulation protocol known as Generic Route Encapsulation, GRE. It's a standard, it's not something Microsoft has made up, but we're contributing to through network virtualization. So what we need on the physical layer is a routable fabric, and in this case they don't have to be on the same exact subnet. You'll see these particular two hosts, 2.10, 5.12. As long as they're routable, that's all that's necessary. They don't have to all be on the 2.x subnet or the 5.x subnet. Now, when we create VMs on top, these two VMs are running on different hosts. So one's on a host that's 5.12, one is on a host of 2.10, but they're in the same VM network, and they can communicate with one another, no problem. They're part of the same VM network and same virtual subnet ID. And how it encapsulates that packet, what gets essentially sent across the wire is IP address source, IP address destination, MAC address of source and destination, just like a normal packet on the network. But then what gets added to this particular packet is a GRE key. Essentially that says what VM network is this part of. That gets bolted on the end of the packet. And then finally, because it needs to get across the physical network somehow, that's where we bolt on the physical encapsulation elements of that, the physical IP address, the provider and the source and destination IP addresses at the physical layer. So that's what effectively becomes the packet that traverses the actual physical network. And if we see that a little bit more deeply in a little bit more detail, we can see here we've got a Hyper-V host and a VM, blue 1, blue 2 on the right-hand side, and these two want to communicate. They're running on independent Hyper-V hosts, 2.10, 5.12, as you can see at the bottom there. They've got their MAC addresses. And this is the Hyper-V extensible switch we talked about earlier on. So what happens when it traverses, this is blue 1 wanting to send something to blue 2. And it's got to traverse the physical network infrastructure to achieve this goal. Firstly, just like a regular Windows server on the network, if it doesn't know where a particular OS that it wants to speak to is, it'll send out an ARP request. oh, hello, where are you? Where is 10.10.10.11? So it sends it out of its virtual network adapter. Remember, the VM doesn't necessarily know it's virtualized. It just sends out the packet. It's captured by the Hyper-V switch. It broadcasts that ARP on its VM network VMs that are on the same host. So imagine more blue VMs running on that particular Hyper-V host, because it first wants to check, is the VM that it's asking for actually located on this host? If it is, we'll find it a lot quicker. Okay, I'll broadcast it locally. If it can't find it, then it broadcasts it to the rest of the network. However, this is intercepted by the network virtualization filter. It's not broadcast onto the physical network at this stage. It's captured. The network virtualization filter checks that policy table we talked about earlier and responds with some relevant information, in this case, the IP, the Bluetooth MAC address. And the filter sends it back up to the Hyper-V vSwitch and onto the Blue One VM. So what it means is Blue One VM now understands what it needs to communicate with Bluetooth. So it prepares its packet, constructs the packet. It's got its source and destination IP and the source and destination MAC, just like a regular Windows OS would have. It passes that packet out of its virtual network adapter. This is intercepted by the Hyper-V switch, which attaches the VSID, the virtual subnet ID. This is what identifies the particular blue network or red network or green network or whatever you've called your networks. Once it goes through the network virtualization part of the switch, it bolts on the details it needs to get across the physical network, which includes the source and destination IP of the physical hosts and source and destination MAC of the physical hosts. So it encapsulates, it's kind of like sending out a letter. You know, you've written your letter, you've put the address on there. The envelope is how it's going to traverse the physical mail system. What's inside is effectively the message, the packet. So that may be one way that helps you think about it. It may be completely sidetracking you, so ignore it if it is. But we've sent that packet now across the network. It's got to the target host. But it's at the target host, it strips off that GRE layer. If we look back on the graphic here, strips off that piece, passes it up to the Hyper-V switch, which identifies it's on the blue network, and then passes it through to the blue VM. And this is completely automated, and within the Hyper-V and VMM world, you don't have to worry about this necessarily. The key things to think about are, we don't need VLANs anymore. We're utilizing network virtualization to handle the isolation, and we'll see how easy it is in a second to actually create one of these new virtualization networks. The final part before we create a new network. What happens if these VMs within these isolated networks need to communicate out to the rest of the world, or to a physical machine or a laptop or desktop on the network that doesn't speak network virtualization? We need some kind of translator, some kind of bridge between network virtualization and non-network virtualization. And that's where our gateway comes in.
And so this gateway, what's it looking at? Is it looking at the incoming and outgoing IP address packets, adding the GRE, stripping the GRE, and redirecting?
It'll be taking into account all of those different things of the target and destination. It'll look at whether this has got GRE, or I mean, if it's come from a laptop, for instance, and it's handling that translation and wrapping the GRE so that packet can get through from the laptop, which doesn't speak network vert, through to the Blue One that we saw earlier, for instance.
How much is that going to cost people?
Good question. It's built into Windows Server 2012 R2. So it is a feature, a role. You can enable it on a single Windows Server 2012 R2 machine or multiple for resiliency. It supports BGP for dynamic route updates, encapsulates, de-encapsulates the GRE packets. It's multi-tenant aware. It's got a site-to-site VPN built in to connect your different infrastructures. And it effectively, as we see on the graphic here, it's allowing Contoso and allowing VMs in the blue network within Contoso to communicate out to the internet. So we'll do things like NAT as well. It could allow VMs in Fabricam to talk to the ones in Contoso if you've connected it that way. Essentially what we've got on this slide is a better description. Contoso and Fabricam are two enterprises. Service provider here is hosting some VMs for Contoso, some VMs for Fabricam. The service provider is using network vert. The Contoso and Fabricam enterprises may be using network vert as well. But these network virtualization gateways are allowing the three to talk together and allowing the service provider to allow NAT access and external connectivity through to those VM networks. There are third parties building these network virtualization gateways as well. Partners, Iron Networks, I think Arista have got one.
And we can plug into those, of course,
absolutely,
right?
Yeah, absolutely. You can bring those into VMM, so VMM manages all of this. So let's take a real quick look at building out one of these virtual networks. So let me quickly log back into my...
Now, while you're switching over, I'll tell you how I personally love network virtualization, how we can take advantage of it here at Microsoft. So I build lots of VMs, right? I build all of these labs. I don't really want to have to think about how am I going to label each of those VMs so it doesn't impact what my neighbors do and what any of the other evangelists in our orgs are doing. So I kind of have my own gateway. I have my own full range of IP addresses. I'm able to just go spin up VMs, deploy them, set up my own DHCP servers, my own Active Directory domains, and I'm in a bubble. As a developer, I can have the freedom to do what I want without worrying about impacting the rest of our environment. So this gives you that isolation, that flexibility, and it's really going to unblock a lot of your internal teams, internal customers from being restricted based on your own networking, organizational protocols, divides, that type of thing.
Great, excellent, perfect fill time. There we go. So, I've now got my environment up. I'm back in VMM. We should be familiar with it now. There's our two VMs, doing well. We've got VM networks here, and you'll see that's the one we created earlier when we actually created our first logical network. But ignore that for now, because what I'm going to create is VM networks. I'm going to go create new VM network, and I'm going to give this a name. Imagine we've, to use Simon's example before, we've got a new group who've come on board. They need some dev environment space. I don't want to create them a VLAN specifically, so I'm going to create a new VM network that I'm going to call Development LAN. In this case, in fact, I'll call it Development LAN to be correct. It's going to sit on top of a particular logical network. I'm going to choose Contoso LAN. So this is the underlying provider network, if you will, the routable network, on the physical fabric that this virtual network is going to sit on top of. So providing all of my hosts are attached to this logical network, VMs could float across all of those hosts and quite happily embrace network virtualization. So we'll go next. How am I going to isolate this? No isolation, which would essentially connect this VM to the management network, which is not what we're going to do, or isolate using Hyper-V Network Virt. Yep, we're going to use that. It's IPv4 or 6, one or the other, not simultaneous. And for the logical network, IPv4 in this case. Now, VM subnets. What is this about? This is about when we're deploying VMs on top of this VM network, there's going to need to be an IP address scheme. In this case, I'm going to create 192.168.6.0/24. Don't really want that to be the name, so I'll just... Where's my mouse gone here? Oh, there we go. Just went off for a second. I'll paste it in there, and I'm going to call this one DevLAN. That's fine. And we'll go next. Now, connectivity. This is where I would specify my gateway. What this would mean is that VMs deployed on DevLAN within the VM network that I've just created would be able to utilize a gateway that's specified here to communicate out to the rest of the world, to the internet, whatever it may be. But I'm just going to go next because I haven't set that up. And I'm going to go finish. So that is it in terms of creating a new VM network. It doesn't get any easier than that. It's just a few clicks, could be done through PowerShell, and I could create lots and lots of those, up to 16 million VM networks. So well beyond the 4,095 VLANs that are capped at VLAN capabilities. So now that we've got our DevLAN, let's go back in to our environment. Let's see a few other things that we can perform. So we've got our DevLAN. I'm actually going to create one more, if I go home, I'm going to create one more VM network called, for test VMs. I'm going to use network virtualization again. The subnet is going to be called test LAN. And what a coincidence, the subnet is going to be exactly the same, 192.168.6.0. Again, no gateway, so we'll ignore that, finish. So what we've created there, just in a few clicks, we've got a LAN for our development VMs and a LAN for our test. Never the twain shall speak. So these two networks are completely isolated, just in the same way they would be if you'd have put them on completely different VLANs. The only difference is now I don't have to go and change any VLAN tags on my host NICs, on my physical switches, top-of-rack switches, aggregation switches. Doesn't matter. They're just going to be isolated no matter where in the cluster our VMs reside, or where on the infrastructure our VMs reside. It's not just a cluster-specific setting. Now the next step is to go into DevLAN, and I'm going to create an IP pool. Because just like we saw before, VMM can deliver out IP addresses, not just at the host level, but also in the VM networks. So I'm going to call this one Development IP Pool, It's going to be that subnet. We'll go next. The range, it's already determined as that based on the specific settings already defined. So I'll just restrict that to 50. So there's going to be 49 addresses. Any reserved addresses? Nope, not in this case. So we'll go next. No gateway, DNS. You could set all that if you want, but I'm not going to for the time being. And finish. So now, that dev LAN, whenever VMs are deployed into that, they could be issued, or they will be issued an IP address by VMM. Now, you wouldn't need that if you had a DHCP server in that dev LAN. That's up to you, though. I'm not using that, so I'm going to deploy my IP addresses manually. And I'm going to quickly do the same for test VM. So test, we'll restrict that to 50. Next, finish, done. There we go. Quick as a flash. That's 2 VM networks defined with IP pools. Rapid. It doesn't take long at all. It's incredibly quick. So we're good to go there. So now we can actually start to assign these virtual networks to virtual machines that we've created, either at deployment time when they're fresh VMs or when they are already existing VMs. So let's have a look at what that looks like in action. Let's go to my Hyper-V or Contoso cluster. I'm going to select one of my VMs. In this case, I'm going to select VM01. Click Properties. And I'm going to choose hardware, VM hardware. Remember, we're looking at a VM setting here. Network adapter 1. I'm going to connect it to a new VM network called, in this case, should we choose dev or should we choose, we'll choose development. OK. MAC address will get automatically configured. Don't need to do anything else for the time being. And I'm going to do the same for VM2. So I'll click OK there. Go Properties, and do Hardware Config, and change this one to Test. So we've now deployed these 2 VMs onto completely different VM networks, and so now these 2 could never talk to each other unless we had a gateway that enabled that functionality. But as it stands now, they are on 2, so if they were running, they could not exist on the same network. They're on the same physical network, sharing the same shared multi-tenant infrastructure, but VM1 and VM2 would not be able to talk to one another because one is on dev network, one is on test network. It's as easy as that. And if we look at the properties of VM1 actually, just to see what's been assigned here, if I look at network adapter again, I look at connection details, you'll see VMM has provided it with an IP address, the first one in that pool. There you go, easy stuff. And that is the power of network virtualization. These machines are completely isolated. They're on the respective subnet now. And if we started them up and tried to ping each other, even if they had identical IP addresses, they would just not conflict because network virt isolates them completely.
Awesome. Well, that's a great summary. I think, have we finished this section?
We've finished all of networking now, yeah. So
all of networking. So a lot of networking, but as you can really see, we've really tried to think about networking end to end. The physical networks, the virtual networks, translation between the two, deploying physical on top of the others, host networking. So throughout this set of technologies, very little things that we can't do. And what we can't do, we have our extensibility partners.
Yep.
Send this extensible switch over to one of these extensible services and take advantage of the full networking capabilities there.
Yeah.
Well, with that, we're going to take a 10-minute break. After we return, we're then going to move on to virtual machine templates and service templates with a lot more coming up too. We'll see you soon.